I'm back again. My name is Rory Kennedy, for those who are just joining us now, and I'm the Director of the Nuclear Science User Facilities. We're going to discuss the NSUF, give you an overview, and talk about the work scopes that are just the NSUF access only, and then we're going to give you a general discussion of the Consolidated Innovative Nuclear Research Funding Opportunity Announcement, and that part of it will be covered by the Deputy Director to the NSUF, Dan Ogden. So just to give you a quick outline of who's doing what you just mentioned, I'm going to give you a little background, talk about the NSUF, and then talk about the work scopes. Dan will cover the FOA, and then we'll be open for questions at the end. So the NSUF, and the reason that I'm here giving this webinar is that the NSUF call was integrated a couple of years ago. This is our third time through into the Consolidated Innovative Nuclear Research FOA. The reason for this was because the NSUF, and we'll discuss this again here in just a bit, a user facility does not traditionally support the underlying R&D funds needed to do research. That would be the travel, the salaries of faculty, graduate students, whoever it might be. It only offers the access to the capabilities at no cost to the users. Traditional model for a user facility, and we're following that as well as we can. However, the Office of Nuclear Energy did recognize this need and the time lapse between getting R&D funding and be able to get access to the NSUF. And many of the projects that come through the NSUF are very large projects that can last multiple years and cost, in some cases, multiple millions of dollars. So the idea was to try and allow proposers to couple R&D funding to access to NSUF capabilities in order to put together a full project that has the R&D funding and also the ability to use the capabilities that are needed to carry out that research. Those capabilities often being unique, expensive to maintain, very distributed across the country in isolated locations or so, often at national laboratories. And so it's not something that could be done. Our capabilities can't be normally set up, many of them, in just a small laboratory on a benchtop somewhere. The other thing is that we did since FY17 is that the NSUF will fully forward fund every project. We had some delays in some projects in the past because we were going on a year-to-year annual budget on allocating funds on whatever projects we could. The decision was made with the Office of Nuclear Energy that all projects will be forward funded, that virtually guaranteeing that we will be able to conduct the research on a schedule, on a budget, and at the locations that we need to. Since we've done this, we've seen the interest and the support levels for the NSUF increasing. And we're very grateful to the Office of Nuclear Energy for all the support that they've been giving in order to promote us and get us into a larger organization. And if you see on the slide here in 14, we only had about 800K worth of support we could give. We got 8 full proposals at that time. We have changed our process in the meantime. Dan will talk about that. And we're able to we made 3 small awards. In 15, when we started to integrate with the CI&R FOA, we started to grow. We got about $4 million. This is where we changed the process. So we asked for letters of intent. We go through the same process. This was added into, just for NSUF, into the CI&R, that we asked for a letter of intent because we have to start working on whether we're able to do these projects, some of them very large, right from the earliest possible date. Then we got 31 out of those 41 letters of intent. We got 31 pre-proposals, and we were able to fund and then out of those 31 pre-proposals, we got 17 full proposals. Out of those 17 full proposals, we were able to make 5 awards that year on the 4.1. One of them was coupled to R&D dollars, and 4 of them were NSUF only. Now the next year, which was this last year, in the FOA, we announced we had $5.7 million available. This is because we don't know exactly what our budget is at the time that we make the announcement. But we figured we thought we would have 5.7 million. What we wound up having for our budget was we were able to make $9.7 million worth of awards. Though that $9.7 million in awards came from, again, a further increase in the interest in the NSUF and coupled to the R&D of 80 letters of intent. We got 67 pre-proposals, 32 full proposals, and we were able to make 12 awards. Of those 12 awards, 2/3, or 8, had R&D dollars coupled to them, and 4 of those were NSUF only. This year, as we come into this FOA that we're giving the webinar to right now, again, we have to look at minimum budget requests, and we're estimating right now that we'll have it at a minimum, again, about $6 million in the FOA. We have, of course, very high hopes that our budgets will be significantly higher so that we can offer even more awards, more projects to the nuclear community in order to fulfill the mission of the Office of Nuclear Energy. I would just like to take a minute here, this little opportunity, to promote supporting the nuclear science user facilities, particularly if you become a user. And we are offering you no-cost access to very unique and important facilities and capabilities. First is to join the users organization. This is a very strong conduit for NSUF, the management of the NSUF, to the user community in order to gain information. We ask the user facility to conduct surveys to find out the information from users. What are their wants, needs, criticisms, compliments, etc. So please join the users organization. There's no cost to that, and your participation is very important. Second would be to attend our users meeting, which gives you an awful lot of information on the capabilities and the types of research that is going on through the nuclear science user facility. The third would be as you become a user and you are conducting your research and pushing back on the challenges that face the materials world in the Office of Nuclear Energy, is if requested, we do ask you to have a positive response to presenting your research at our annual meeting, which we give to the Office of Nuclear Energy for review, but also we have a science review board and who tries to keep us on track and to ensure that we are doing the proper research. So if we do have requests for you to come and present at this, I do hope that we'll receive positive responses. The other is we would like to encourage our users to engage the nuclear community more. One of the primary ways we have of doing this are through exhibits, and the NSUF exhibits at a number of conferences and meetings throughout the year. The ones coming up over the next 6 months or so will be at Top Fuel, which is in Boise in September, next month. We'll be at the ANS Winter Meeting and Exposition, which we are typically there. That's in November. We'll also be at the Nuclear Materials Conference, NUMAT, in France. This is a very important meeting for us in conference because it is nuclear materials and just concentrated on nuclear materials. We'll be at the MRS Fall meeting in Boston, and we'll also be at the TMS meeting in San Diego next year. When you are at these meetings, if you come by the exhibit, hang around, engage whatever community is around in order to draw more people into the nuclear arena, explain to them about a lot of the challenges that we have in material science and in nuclear, because we would like to expand our scope on our users and the intellectual capital that we bring into answering the questions in order to fulfill the mission of the Office of Nuclear Energy. So, if anyone who saw the infrastructure talk just before this, we will launch a new website. We're updating our website for the NSUF. This is the current homepage that you go on, and we've had some comments particularly from some of our younger users that it's not very modern and up to date. So we are updating it, and this is what it will look like when we launch this. We are hoping to launch this within the next week, but if anyone has had any experience with websites and these types of things, there are 100,000 ways that things can get delayed. But we will launch our new website, which will be coupled to, integrated with the Nuclear Energy Infrastructure Database and our Nuclear Fuels and Materials Library database through our new website. So we're very excited about that. It's much more user-friendly. You can we're gearing this so that you can have it on your desktop computer or your tablet or mobile devices, which the current one doesn't allow. Single sign-up for proposal systems, and it enables us to better highlight the work that we do. And just quick little slide here, you can scroll down, and it's much better, nicely organized on being able to get into whatever information you might need from our website. So again, we can just back up here just a minute and go over what the NSUF does and what we support and what we don't support, because this is very important. The primary purpose of the Nuclear Science User Facility is to provide access to capabilities that are available to the Department of Energy Office of Nuclear Energy in fulfilling their mission at no cost to the user. This is your classic user facility model. I mentioned before that our projects can be very large and very expensive. Our largest projects are irradiation, and irradiation for the largest would be in a nuclear reactor. We also offer irradiation through ion beams, which we mentioned here below. And then the post-irradiation examination. This could entail using hot cells, which anyone who has worked in hot cells know that the process is much more safe and secure than just working on a benchtop. Not that benchtop work is not safe and secure, because of course everyone works that way, but what we have to go through to ensure the safety and security is sometimes more intense. We can also just do irradiation only if you would like, and then if you have support to do the post-irradiation examination somewhere else under funding, that's perfectly fine. If we already have samples, and again, this is where our Nuclear Fuels and Materials Library comes in. If the materials are already available, we can just support the post-irradiation examination on those materials. Beamline, I mentioned before the ion beam. We offer ion beam irradiation. Dan will talk about that, where that's available to us, and that may expand for us in the future. We've recently had an ion beam workshop, and we'll be putting together a roadmap for the Department of Energy Office of Nuclear Energy in order for them to make some decisions on where to go with ion beam irradiation. And we are trying to expand our synchrotron availability. This is through other user facilities. These are the ones we are working with at the moment are our Office of Science at the Advanced Photon Source. It's the MR-CAT line. Dan will talk about this. And we're very close to finalizing a partnership, a relationship with the National Synchrotron Light Source 2 at Brookhaven National Laboratory to be able to offer synchrotron X-ray capabilities. Another that we started just this past year is we're offering high-performance computing. Again, Dan will discuss this a bit. This is offering CPU time, but we are strongly encouraging using the developed over the past, maybe close to a decade now, the Moose, Bison, Marmot, and other modules that go with that, but using the Moose platform for fuels and materials modeling. We do have some restrictions, as I mentioned before. We do not offer directly through NSUF any underlying baseline R&D support for any particular project. That means travel, salaries, other user costs. The source, we are requesting this year, if you want NSUF access only, which is the NSUF2, that you identify your R&D funding. We want to ensure that the user has the funding base in order to perform the work that needs to be done, and NSUF will offer the access to the capabilities at no cost to them. Also, the NSUF, we are concerned with, and our role comes in, as I said, with irradiation, radiation only. We come in at the point that the materials are ready to be irradiated. If there's development work that needs to be performed up to that point, we request that you do not put in an application to the NSUF yet, but complete those preliminary work, and when you are ready when you are ready for an irradiation test, then put in an application for us. If we would prefer that all the materials are already available, but we can make a couple of exceptions to that. One is if the process is absolutely well defined, then we do invite proposals, because then we have high confidence that you will be able to produce the materials, because we produce the materials that are necessary in order to carry on further with the NSUF. Or if the final, if the materials themselves are highly radioactive or require special handling, for example, certain isotopes of uranium or the transuranics, work out the process, the preliminary before on surrogates, and then when it comes right down to the end, producing those final materials, which do require special capabilities, we will gladly work on that. So those are just some of the restrictions that we have, you might call them. All right, so going directly to this CINR that's coming out now compared to last year. Before we dropped the NEAT part of this, even though we do come through the nuclear energy enabling technologies area within Office of Nuclear Energy. We've just dropped that, and we just have the work scopes NSUF1, which will have R&D funding attached, NSUF2, access only. And that's what I'll be mentioning here in a minute. We do encourage experimental and computational projects. As I said before, we're offering high-performance computing, and we would like to utilize this. We have a significant amount of CPU time available to us on the Falcon machine at the INL. And Dan will talk about that machine when he gets up here. Important to this is Appendix D in the CINR, the data needs for validation. There are parts in this data needs for validation that you can use to gear your projects for NSUF support, coupling experiment with computation, and answering specific questions about specific phenomena that we want to understand in the materials and fuels arena. So as I mentioned before, the NSUF1 will be covered by the particular R&D funding sources, work scopes. They're fairly narrowed down because of the limitation in the funding on particular topics. Those will be discussed here in order. I will move into discussing the NSUF2. These are projects only requesting access to NSUF capabilities. The R&D funding is already secured, but we do ask you to describe what that funding is and the duration. So we are fairly broad. I mentioned before that we were going to the work scopes that will come through coupled to R&D, maybe narrowed down for particular topics, but we still at NSUF access only, keep them fairly broad. Core and structural materials, we're interested in material aging, degradation mechanisms, development of radiation-resistant materials, of course, are always at the forefront of research in the nuclear area. Fuels and advanced fuels, understanding fuels behavior and advanced fuels. So fuels in reactor, including the fuel cladding interaction, proving the performance of current fuels, research into advanced fuels. Of course, we have the accident-tolerant fuels, are high on the radar screen these days. Understanding the mechanisms, the thermophysical and thermomechanical properties, the microstructure, the relation to microstructure on all of these properties. Projects should aim at proposing irradiation experiments with PIE investigation of fundamental performance aspects, all related to this. These are the big projects: radiation damage, species diffusion and migration, fission product behavior, and a host of other type of phenomena that we want to understand. Fairly broad there. Instrumentation development. Instrumentation development is very important, particularly in the area of in-pile instrumentation. If we want instrumentation development for PIE, we can talk about that also, but we're looking for, what a very strong interest to us is the in-pile instrumentation development. So you have your sensor, or even the materials will support the irradiation testing on those to see what the performance is like, and that what we're looking for, dimensional changes, crack propagation, crack initiation would also be super, holy grail. Fission product pressure, it's a non-intrusive, we're looking for non-intrusive tests, microstructure development, etc. Online monitoring of parts of the power reactors, and we're also interested, I don't know if I'd call them necessarily blue sky, but non-traditional techniques, and a very strong interest, of course, within that realm is wireless transmission of data from inside the reactor core or even inside the fuel pin or plate to the data collection system sitting somewhere on the outside. I mentioned the synchrotron radiation. We would like to enhance this. These are very powerful tools for doing fundamental science, and in this case applied to nuclear fuels and materials. We have the MRCAT line at the Advanced Photon Source. This is available to us through the Illinois Institute of Technology. X-ray diffraction, absorption, fluorescence is available at the MRCAT line. I mentioned before that we are in the final stages of securing a relationship with the Brookhaven National Laboratory, the National Synchrotron Light Source 2, and we will be offering the X-ray powered diffraction beam line. We plan to offer it is in the CINR. We have to finalize the agreement, but we will offer some time on the X-ray powered diffraction beam line. And of course, all of these are fundamental aspects of irradiation damage for the synchrotron light source. So to end, we have our federal point of contact is Allison Hahn, who was up here at the end for the infrastructure. She will be giving another presentation, I believe, on tomorrow. And of course, I'm always available and happily, willingly available to discuss anything with anyone at any point, and that's my email address. And with that, we will close my portion of this. And do we want to take questions now, or do we want to wait for Dan?
There are a few questions related to your presentation. We can clear those out and then answer everything at the end.
As well as we can.
How can we access the list of existing materials in the library?
Go to nsuf.inl.gov, and there should be, and there better be, a link to the library there. And right now it's pretty much just in spreadsheet form. We're in the process of modernizing and updating and making this a web interactive, but it's pretty much in web space. But you better be able to get it through our website.
What PIE infrastructure do you have at your facilities?
Please go to the nsuf.inl.gov on the website, and that gives you all of it. It's way too much for me to stand here and recite, but we have reactors. And Dan will discuss a little bit of this, so you can hold off on that. But I can just say we have nuclear reactors. We have 4 of them. We have the Advanced Test Reactor. We have the High Flux Isotope Reactor at Oak Ridge. We have the MIT reactor, and we have the Pulsar reactor. All of them with different power levels and different capabilities, conditions. We have hot cells, primarily located at the national laboratories, but also we have a couple of universities that have some. And then we have a host of instrumentation that's distributed across the country at INL and our partner facilities. It's all on the website.
Is it possible to irradiate previously irradiated materials in ATR?
Yes, anything is possible. However, that's a very expensive process. It depends. Okay, if they're ion irradiated, then it's actually a simple possibility, so because we include ion irradiations in general irradiation. If their fuels irradiated, it all depends upon the level of activity, what needs to be done, and becomes a very expensive proposition because we probably may have to do welding inside the hot cells or figure something out. But anything is possible. It will all depend upon what the exact materials are, what the irradiation was. But this is a very interesting area of investigation, I can personally speaking. But there's a lot of considerations, but yes, it is possible.
Okay, those are all the questions we have right now for Rory. I did want to make a clarification about the NSUF-1 work scopes. There is the NSUF-1 work scopes, but there's also one NSUF-related work scope in Appendix A titled NEAMS 2. So please be aware that that is available for NSUF access with R&D support.
I'm going to start with some changes from last year in the FOA. Rory's already touched on a couple of these, so I won't need to dwell on them. We have dropped NEAT from the work scopes just for clarification. Rory has already mentioned that we're adding the X-ray powder diffraction beam line at NSLS2 to the suite of NSUF capabilities. The agreement should be signed prior to the end of this fiscal year. We also made an important distinction to clarify the access to the Nuclear Fuels and Materials Library. There's been some confusion on this in the past, but all of the contents are owned by the Department of Energy. We do highly encourage collaboration with the previous principal investigator that researched these materials, but we want to make it clear that permission is not required from the previous principal investigator. Continuing on with changes, Rory Kennedy has also touched on this, but it's important that the applicant is ready for NSUF access. Materials and samples should be available at the time of full application or have a well-established process with equipment and resources available essentially on demand so that the samples are available approximately 5 months after initiation of the project. So this would mean about the March time frame. Applicants should be prepared to have their samples available. That's when we need them so we can encapsulate them to put them into one of the reactors. Pre-irradiation characterization of the material should be complete at that point. Also clarified that we have limited the PIE phase of all projects to 3 years in duration. This isn't really a major change from last year, but more of a clarification so that everyone knows what our expectations are there. We're also looking for a publication list from prior NSUF access awards. Those of you familiar with any other user facility know that tracking those publications is an important metric. And for some reason, it's sort of like pulling teeth to get all of those publications. So we're asking for that information in the application. An important clarification this year, the user agreement, which is an appendix in the FOA, is a non-negotiable document. Acceptance must be indicated in the LOI, the pre-app, and the full proposal, or we will not review those documents. So be sure to take a look at that early. Have your legal department look at that and get a jump on it. The time frame between now and the LOI and the pre-app is fairly short, so you probably should start on that very soon. Fusion energy studies are not relevant to the NE mission. We just wanted to make that point. That's an Office of Science area. And a reminder that the LOI due date is August 29th. Pre-apps are due on September 14th. A few other reminders. Uninvited applications will not be reviewed for NSUF access. The Department of Energy does reserve the option to decouple an R&D request from the NSUF access and evaluate and fund either portion if feasible. This only applies to the NSUF-1 work scope area. High performance computing capability does have access through NSUF. We'd like to see more proposals that are taking advantage of that. We're also asking to to see the source, scope, and duration of R&D support for NSUF access only. And I think we've already touched on the dates. Hopefully everybody has those drilled into their minds. Okay, now I'm going to do a fairly quick overview on NSUF. How are we doing on time, Drew? I don't see. Good, okay. This will cover the basics of NSUF, starting with the very beginning of what is a user facility. Some of you may not have taken advantage of DOE's user facilities. Office of Science has the majority of those. There's currently about 50 of them, maybe 52. These offer unique experimental capabilities to researchers, typically at no cost. The access is through a competitive proposal process. And beginning in 2007, the ATR National Scientific User Facility was created to address the specific needs of the Office of Nuclear Energy. And that is the beginning of NSUF. We currently provide access to multiple test reactors, the Advanced Test Reactor at the INL, as well as the ATR Critical Facility. We have access to the MIT reactor, the High Flux Isotope Reactor at Oak Ridge, the NRAD reactor at INL, as well as the Polestar reactor at North Carolina State. It's a variety of reactors with a variety of capabilities. Covers a pretty good spectrum of neutron irradiation. Ion beam capabilities available through NSUF. We have access to the Ion Beam Laboratory at the University of Michigan and the Tandem Accelerated Ion Beam at the University of Wisconsin. We also have access to the Intermediate Voltage Electron Microscope at the Argonne National Laboratory. A unique capability there with an electron beam and an ion beam coupled, as shown in the slide. Synchrotron irradiation. We've always had access since the beginning to the MRCAT beam line at the Advanced Photon Source. This year, as we have mentioned, we're bringing online the X-ray pattern diffraction beam line at Brookhaven, NSLS2. We've got an extensive suite of hot cell capabilities available throughout our facilities with a variety of capabilities inside the hot cells. We had a question earlier about PIE capabilities. As Dr. Kennedy said, that's a rather long list. This slide here just has a sample to whet your appetite. Electron microscopy, a variety of other very sophisticated examination techniques available. The best thing to do is to visit the website, take a look at what's there. You can query the NEID to also look and see what capabilities are available. A lot more information than we can present on this slide. Back to high performance computing. Dr. Kennedy mentioned the multi-physics object-oriented simulation environment. There's a link right here on this slide, and we would encourage anyone interested in a computational and experimental project to visit that website if you're not familiar with all the various codes that are available on this platform. Some information about where our Falcon computer stands, currently ranked about 170 in the grand scheme of high performance computing. Okay, in addition to all these capabilities, an important part of NSUF is our technical staff that comes along with NSUF access. This is just a short list of technical expertise that's available through NSUF, supporting not only the programmatic aspects from the DOE standpoint, our NSUF staff, expertise with neutron irradiation, ion beam, synchrotron irradiation, and of course post-irradiation examination. We have a large staff available to us to support execution of these projects. This slide has our NSUF consortium, a group formed to undertake an enterprise beyond the resources of any one member. This is truly the unique aspect of NSUF, as we are not a single facility. We have access to capabilities at many facilities. Research tools, I think we've already discussed these quite a bit, so I'm not going to dwell on those. There's some additional contact information on here. Folks on our NSUF staff, Kelly Cunningham, deals with the Nuclear Fuels and Materials Library, and Jonathan Kirkham deals with the Nuclear Energy Infrastructure Database. Both of these folks work for Dr. Brendan Heydrich. A couple other folks there that can help you with specific queries. Okay, accessing NSUF. Our research menu really is a la carte. It can be neutron irradiation, ion irradiation, synchrotron irradiation, or PIE. Overall, the process drivers for NSUF access, as discussed earlier, we forward fund these projects, so the access must be feasible. We do have to determine the cost of the access so that we can fully fund the award. And this is not something that applicants can do on their own. You will need assistance from the NSUF staff to do this. The process is described in the FOA in Appendix E. The letter of intent is a critical and mandatory first step due August 29th. The letter of intent establishes contact with a NSUF technical lead who will be your new best friend, help work you through the process. Depending upon if you're interested in using multiple facilities, you may have more than one technical lead working with you to help determine if your proposal is feasible and what it's going to cost. In the back of Appendix E, this process is laid out along with a narrative that describes how things work, sort of in the background on the NSUF feasibility study. I'd encourage you to read through this as you're getting ready to submit your LOI. Contact us if you have any questions. And now we're ready for questions. So I think Dr. Kennedy is going to come back up. Allison, are you going to join us up here, if you like?
Can you please repeat the eligibility requirements for NSUF access grants, both in the NSUF 1 and NSUF 2 categories? I can probably cover this from yesterday.
Go ahead.
So the NSUF 2 access only do not have any eligibility requirements associated with them, meaning if you are a university, national laboratory, or industry collaborator, you can submit an NSUF 2 access only application regardless of what you currently have. The access or the eligibility restrictions for the NSUF 1 work scope and NEAMS 2 work scope, which are both NSUF related, are that university PIs can submit up to 6 applications, but no more than 3 as the lead PI. If you have a currently funded IRP or more than 3 currently funded R&D awards, you are not eligible to apply. The other eligibility restriction is if you have an existing no-cost time extension that will go past December 31st, 2017, you are also not allowed to apply in the NSUF 1 category. And an important distinction here is that all NSUF applications are on a case-by-case basis on the eligibility requirements outlined in the CINR FOA. So please refer to those eligibility requirements. If you do have any questions, contact the INR integration staff. Contacts that are listed on the FOA page. Where can we find the costs of your NSUF access, including HPC resources, so we can draft an appropriate request?
You won't be able to go anywhere on a website and find NSUF access costs. That's what the process, the NSUF feasibility process is for. So if you review Appendix E, that will help clarify how that process works. One of the initial steps is to develop a statement of work which defines the scope of the access request. Once we've defined that, we're able to do cost estimates at each facility to determine what the cost of the proposal will be. So this process kicks off essentially with the letter of intent, And the NSUF staff works with the applicants through the pre-application process all the way up to the submittal of the full application to develop those costs, help the applicant understand what they're asking for, what things cost, and adjust their application as necessary to be what they think is competitive prior to submission.
Let me just mention a sidebar to that. We hope to eventually, in the nuclear energy infrastructure database, to have this type of information associated with all the capabilities. If we get it, the hope is to have it fully populated so that you will be able to know how much X time on X instrument is going to cost. But again, this only comes from the facilities themselves, the willingness to give this information that they've developed it themselves. But at this point, and probably for the foreseeable future, establishing a cost for any particular project runs directly through the NSUF in direct negotiation and relationship.
Which means as you're putting your application in, no budget documents are required for NSUF2 access only. Those, you'll see that they're available on the form, but they're not required. A previous presentation mentioned the FOA release on September 1st. The NSUF LOI is due on August 29th. Am I reading this correctly, or is there a different FOA?
The infrastructure activity is a separate FOA, and a letter of intent is not required for the infrastructure FOA.
And the infrastructure application, which is on a completely different schedule than the CINR FOA, is submitted through grants.gov, whereas the CINR is submitted through NEUP website.
Do you expect us to finish all pre-irradiation work to submit an LOI for irradiation-related studies at an NSUF facility?
No, because we will go as we go through the process with the pre-application. You will be working with the technical lead. We will get a better understanding of where you stand as far as the preliminary work that needs to be done. If you are invited to give a full application, that's a much longer process. However, at any time during that time period, if we establish that you are not going to be ready at the time of submittal of the proposal, then we will strongly recommend that you stop with the proposal process until you get to that point. But just at the LOI, if you have high confidence that you will meet these requirements for the materials by the full proposal time, then I encourage you to go forward. Keyword, high confidence.
As a reminder, we have talked about two different FOAs here. To reiterate what Dan said, there is an infrastructure FOA numbered 0001516. And there is a CINR FOA titled 0001515, or numbered 1515, excuse me. The CINR FOA is related to the presentation that Dan just gave. That's where you'll find the NSUF1 and NSUF2 work scopes. The infrastructure FOA that was outlined in the previous presentation, those applications are due on November 23rd. And that FOA will be released in September. The FOA for the CINR FOA will be released hopefully by the end of this week. It's anticipated to be released by the end of this week.